Hello, everyone. This recording is for the second week of classes for COE 628 Operating Systems course. Let me share my screen with you. So let me go back here to Zoom, guarantee that my screen is shared. Yes. So before I even start, I would like to bring your attention to some of the research and graduate studies opportunities available on at the school. So the first one is called, if you are not aware of, DRF Undergraduate Research Experience. It's called DRF URE. So this is really good opportunity for undergraduate students on third and fourth year, I believe. So more information that could be found on the following URL. Would be a great opportunity for you to find a potential supervisor working with her or him to establish like a research project funded by the Faculty of Engineering. Another good opportunity is the undergraduate research opportunity, the URO one, slightly higher in terms of the amount of fund. I think it's only available for, let me refresh my mind. I think this one is available for third and second year, and this one is only available for third year students. So this is for third and second year students, undergrad students, and the first one is for third year students. I encourage you to confirm this information by looking to the following URLs as well, and immediately try to communicate or email with potential supervisors in which you could work over summer for a great research opportunity funded by the Faculty of Engineering. And I believe the applications will take place in February, maybe late March. Could you double check on the following URLs as well? And finally, a very good opportunity for those who are interested in graduate studies is to investigate and have a look at the Accelerated Master of Applied Science pathway. And I have also added the following link for your reference. These are great research opportunities over summer term where it's fully funded by the Faculty of Engineering and provide you with a research environment that helps you to either go for graduate studies or promote more actions related to industry experience. So let's now I'll go back to our class. So I would like to summarize what I have actually discussed over last week in terms of some of the earlier concepts that have been covered, and particularly in the textbook for chapter 1 and chapter 2. Because in today's class, we will define processes and more information about the first component of the operating system, which I have referred to previously as the process manager. So before actually defining the term process, it's very useful to summarize some of the concepts that was introduced in chapter 1 and chapter 2 that we actually covered last week. A computer platform consists of a collection of hardware resources. An example of those hardware resources could be the processor, the main memory, the input-output modules, timers, disk drivers, and so on. Also, computer applications, as mentioned before, are actually developed to perform certain tasks. Typically, they accept input from the outside world when we look to the outside world of the user, and then perform some processing and then generate the output. We also know that it's inefficient for applications to be written directly for a given hardware platform. And the main reasons behind this inefficiency could be classified according to three main criteria. The first one is we know that numerous applications could be actually developed for the same platform. And with that being said, it makes sense for us to develop common routines for accessing the computer resources. Also, we know that the processor itself provides only limited support for multiprogramming. That means any software is needed to manage the sharing of the processor as well as other resources by multiple applications at the same time. The third reason that we may consider as a factor for inefficiency for application to be actually directly written for a specific hardware platform is that we know that multiple applications could be active at the same time. And it's necessarily to protect the data as well as the input-output usage and any other resources that we might need it um, for processing by other applications. These are the main reasons that might cause inefficiency for applications to be written directly for a given hardware platform. We also know that the operating system was actually developed to provide convenient and feature-rich, secure, and consistent interface for applications to be used. That being said, we consider the operating system as a layer of abstraction, as I said before, or in a software world, it's a layer of a software between the application and the hardware. And we can actually think of the operating system as this unique layer that provide uniform and abstract representation of those resources that can be requested and accessed by applications. And when I use the word resources from now on, I would like you to stick to either main memory, it might be network interfaces, or it might be file systems, and so on. Once the operating system has actually created these resources of abstraction for applications to be used, it must also manage the usage of those resources. For example, the operating system may permit resource sharing and resource protection. This is more or less what has been covered last week, but in today's class, I would like to go over the first component in the operating system for components with focus on the process manager. So a main function of an operating system is to manage the processes. But before actually we're going over how to manage processes, how the operating system is handling the processes once they have arrived to the extent that are actually fully processed, there are some fundamental terms that we need to go over it. And as well as some concepts that we need to cover, there are some fundamental attributes and properties that we need to address. And this will be summarized in the following agenda. In my agenda today, I would like to give you a definition of program. What is a program? What is a job? And what is a process? In addition to this, I would like to go over some concepts related to how the processes actually are represented and controlled by the operating system. Once we start talking about the control of the processes and the representation, we need to go over the different process states by which we characterize the behavior of the processes, how the processes are behaving in a system. Once we understand the common behavior of the processes, from the moment they have been created to the moment that they have been processed and leave the system, we need to understand how this works by understanding the data structure, the main data structures that are used to manage the processes. There are different ways in which the operating system will execute and use those data structures to control the process execution. What are those ways? That would also be covered in today's class. So let me start by the main definitions of a program. So when we use the word program, when we say, what is a program is just a non-active set of instructions. They are mainly stored on the hard disk. We say a program, so we start by a program, set of instructions stored on the hard disk. The program would become a job from the moment it is selected for execution until it has finished running and become actual a program again. So being inactive means that the program actually just non-active set of instructions on the hard disk. We haven't run it, we haven't executed. We call it a program. And then this program become a job, or we call it, now we have a job in place that we would like to execute it. We call it a job from the moment that it's selected for execution until it has actually finished running and becomes a program again. And then we say a program, a process is a program. So that's the common terminology that we use it to represent a program when it's in execution. So a program is a job. So a job means that couple of processes. So we divided job into many processes. Each of those processes, once they are in execution state, the program will be called a process, or like a composition of multiple of processes. So one job could be one process, or one job could be multiple processes. So keep in mind, it's the program that has started but has not finished yet. So the relationship between a program, a job, and a process becomes even clearer if we consider how a program become a job and how a job become a process. So with that being said, and we cover some fundamentals related to a program become a job, and then a job could be a process or could be a multiple processes. Let me go over a main definition of a process. Actually, there is no one definition. There are many definitions. And actually central to the design of operating system is the definition of the word process. The word process is like somehow more general term to the job. So instead of using the word job from now on, when we refer to an application of a user which has been set in the memory, so it become a program, and then a program is in execution state, we will call this a process. So there are many definitions that have been given for the term process itself. The first one is a program is in execution. So when I say what is the definition of a program in execution, we are referring to a process. When we refer to an instance of a running program, that is a process. When we define the entity that can be assigned to and executed on a processor, this is a process. A unit of activity characterized by a single sequential thread of execution, a current state and associated set of system resources, this is another definition of a process. So could I use each definition individually? As a matter of fact, no. It might be recommended when you define a process to go over all of those definitions all together. So a program in execution, which might be considered as an instance of a running program that can be assigned and executed in a processor and has different activities that are characterized by some sequential threads of execution, current state, and associated set of resources. This will give us a complete definition of a process. So as we define a process, we need to go over two essential elements of a process. The first one is called the program code, which may be shared with other processes that are executing the same program. And the second one is the set of data associated with that code. And actually, it's the data that will be associated with that code is very important to be considered as a process element, because without the data, we cannot actually process or continue executing the process. So we refer to this executing entity that has the program code as well as the set of data. So we do have the program code, which might be shared with some of the processes. In addition to it, we add the set of data. So we do have the data. These two combined will compose the two essential elements of a process. So if this is the only two components that we will use to define the main elements of a process, as a matter of fact, it might be generic to add another one, which we refer to number of attributes that will describe the state of the process. with that being said, a process is comprised of program code with a possible sharing among other processes, set of data that will enable the execution of the entire application or entire program, and the number of attributes that will describe the state of the process. So for me to deal with the process, I need a program code, I need data, and I need a number of attributes that will describe the state of the process. So while the program is in execution, this process can be uniquely characterized by a number of elements related to the attributes that will characterize the state of the process, including the identifier of the process. So each process has its own identifier. The state of the process, whether there is a priority to the process to be executed or not. That means the priority level relative to other processes, the program counter, and the memory pointers, context data, input-output data information, accounting information. All of these are attributes that I will use it to describe a state of a given process. So we will use it to describe a state of a given process.